All right, welcome everyone. My name is Steve Cross, and I am the Technical Director for the Asphalt Recycling and Reclaiming Association, and a retired professor from Oklahoma State University. And what we want to do today is give you a brief overview of or an introduction to cold central plant recycling. So, learning objectives. What we want to try to do in the next 20 to 30 minutes is just get a basic understanding of what cold central plant recycling is. There are different processes, and we want to understand those. I want to learn or tell you about what recycling agents are commonly used in CCPR and their differences in performance. We want to learn what recycling additives are occasionally used with CCPR, and again, their performance benefits. And then just kind of gain an overall perspective of how CCPR is performing. So we'll start off with cold in place recycling falls under the general term that ERA uses of just cold recycling. And so that breaks down into two different parts. There's cold central plant recycling that we're talking about today, and there is cold in place recycling, which is also sometimes referred to as partial depth cold in place recycling, and we will cover that in a separate presentation. So cold central plant recycling, basically it's a viable alternative when stockpiles of high quality wrap are available, and it's occasionally used when it's not possible to in place recycle the pavement. And cold in place recycling is most commonly done using a central mix or cold mix plant, but it can be used, and this is done quite commonly out west, using the mixing and processing portion of a CIR train. And actually, Virginia is probably leading the country in the use of cold central plant recycling with the project they did on I-81 and the subsequent follow-up they did on I-65. So basic overview, and we'll go over these steps for cold central plant recycling. But basically, we want to start with clean. What we do is we start with clean wrap, and we're going to turn this into a new pavement. So at some point or another, we have milled and stockpiled wrap, but it's really important that we keep this clean. We don't want to use the junk wrap pile. We want a nice, good, clean wrap stockpile that you've used proper stockpile management techniques. We're going to size the wrap to the gradation we want. We might supplement it with new aggregate if we think the aggregate in the wrap could use a little improvement. We're going to mix this with water, a recycling agent, and possibly recycling additives to make the mix. Then we're going to transport it to the laydown area. We're going to pave the recycled mix. We'll go over that, but it's placed just like hot mix with just a few minor differences. We're going to compact it to a specified density. Then we need to protect that mix or that surface until we're going to pave over it. So we want to protect it from temporary traffic. We want to let it cure. We might re-roll it before we put the overlay on it. Sometimes you can gain a few more pounds of density. And then lastly, we'll apply a final surface course. As these go down with relatively high air voids, so it does require a surface course to protect it from moisture. So start off, there are basically three different ways you can do cold central plant recycling. There's what we call on-site CCPR, and we're going to take wrap that's milled from the roadway to be reconstructed. We're going to haul it to a close temporary processing site. We're going to process it and return it to the same road. This is used occasionally when you can't get in with the equipment to do an in-place recycling project, but we've seen it done a little more often where I'll combine CCPR with cold in place or CIR to allow me to treat a deeper section. And so what we'll do is mill off the top 3 to 4 inches of the asphalt pavement, then come in and do CIR on the next 3 to 4 inches of asphalt, haul the CCPR mix back down, and now we have a 6 to 8 inch layer of treated material that we've gotten placed and compacted. There's imported CCPR, which is occasionally done, and that is we'll take wrap from one road, haul it to a processing site, and then process it and immediately return it to a different application. But by far the most common, and this is where all the interest is that contractors in Virginia and a lot of other places have large stockpiles of wrap. And it's hard to use all this up, trickling it back into a regular hot mix at 10 to 15 to 25%. So we'll take wrap that's stockpiled from various projects at a central facility and make a cold central plant mix to place. As part of the process, we're going to need to size the wrap. A lot of times with these stockpiles, especially if they've been sitting for a while, you're going to have something to bust it up so you can get into it. But regardless, we almost always put a scalping screed over the hopper that's either going into the central mix plant or the recycling train. That scalping screed is typically set at 1.5 inches, but it can be set smaller. Many times we have to crush this wrap, so we'll crush it and screen it to a maximum size. Across the country, we've typically seen it being crushed to 1 to 1.5 inches maximum size. We're pushing toward lower sizes, so I would say now 1 inch is a little more common. But in Virginia, you've crushed it even finer than that. A couple of different ways we can do this, but you want to use this is a closed loop crushing and screening plant. And actually what you're seeing in the foreground is the processing unit off of a CIR train that they've pulled up and set up. It has a scalping screen, a screening deck, and a jaw crusher set up on it. So the oversize is run to a crusher, fed back through, and everything that fits through the bottom screen size goes to a pug mill where it's mixed, and then it's placed. You can see on my left, you can see the front end loader loading a hopper, and you can see the processed or completed mix coming out into a truck ready to be hauled on site. You can supplement this with new aggregate, or you can fractionate the wrap. Kind of the nice thing about CCPR is it does allow you to control the gradation a little bit better. So here is a process where the contractor fractionated his wrap and added new aggregate. So he had to bring in some extra bins, but you can see in the background he has one bin that has 3/8 inch new aggregate, another bin that had the 1 inch to number 4 wrap, and then a third bin that had the minus number 4 wrap. This would allow him to proportion these any way he wanted. And in the foreground is the processed CCPR mix ready to be transported to site. We also once we've processed the wrap or crushed the wrap, screened the wrap, we need to mix it with water or a recycling agent and add any recycling additives if necessary. So the two most common recycling agents are emulsified asphalt and expanded or foamed asphalt. As far as the emulsified asphalts, the most common that's used now is engineered emulsions. And these are just emulsions. They're typically CSS1 emulsions, but they've been formulated specifically for your materials and locations. We've used polymer modified emulsions in the past. And occasionally, especially if we're making a stockpile mix, we might use something like CMS2S mixed with lime to give it a little longer time in the pile. Expanded asphalt is what you've been used in Virginia. And really all expanded asphalt this is the same thing that's used in a warm mix asphalt technology. But I'm going to take hot asphalt. It's going to be 325 plus. And we're going to run it through a nozzle where we're going to inject a little bit of cold water into that. That's going to cause that hot asphalt the water will vaporize, causing that hot asphalt to expand, and it'll make some tiny little droplets. And then these droplets are easy to disperse through the mix. We'll add recycling additives. These are added in small quantities, and typically we'll either see cement or lime used. As far as the differences between the two, what we see up at the top, you see 2 asphalt pills on top, and underneath are 2 cores taken from the same project. The top ones are mixed design samples. The bottoms are cores from the pavement. So on the left, the lighter colored one is actually foam, and foam is a binding technology, or it's been referred to kind of as a tack welding technology, but it's not a coating technology. It puts little droplets of asphalt that are going to mix with the wrap particles and tack them together. Emulsions is a coating process. So you see in the mix design sample, it's nice and black. But if you look at the cores down below, these were taken a month or two after the mix was placed, I believe, and this is not uncommon. You can't tell which one is which. There's really no difference. We'll point out for the binding technology or the foam to work, most literature recommends you need some fines in the mix. Typically is a minimum of 5 and a maximum of about 20% minus 200. And most of the time, 100% wrap mixes are deficient in that. So we typically add 1% cement. This says 1 to 2, but 2 is getting a little too high typically. So a lot of the times we specify 1% maximum cement. This helps disperse the foam droplets, aids in mixing, and the cement adds in moisture sensitivity. As far as how they perform, the NCHRP 951 project was done by Maryland, but Virginia had a big part in this as well. And they performed dynamic modulus on foam samples and emulsified asphalt samples on cold in place and full depth reclamation. And they came up the fact that they saw no difference in mixed properties between foam and emulsion. Another thing that was interesting is they said it basically behaved very similar to a Virginia base mix. There's very few side-by-side studies of performance that were made with foam and emulsion, but Ontario did a cold in place recycling project, and there's really not much difference between the mix from cold in place and cold central plant. But they placed a foam section and an emulsion section on the same project, and this was Highway 7 near Perth, Ontario. The report is several years old, but they came back 10 years later and did a review of the sections and reported that both sections were performing well with no difference in performance after 10 years. And again, they've been down longer than that. As far as the plants, this is a pretty good photograph of a central mix, cold mix plant. This one happens to be made by Wirtgen. You can see the conveyor belt going up and feeding the plant. The tower you see in the back has cement in it, and off to the right you can see the hot asphalt tankers. This one happens to be doing foamed asphalt. This is a portable plant, easy to move around, and does a really good job. This is probably the most common that you see in Virginia. It can also be done using the CIR train that's placed in the stationary mode. Out west, this is a little more common. And in my part of the country, we have lots of small stockpiles of wrap sitting around at different places. And we've had a CIR contractor come in, park his central mix train, and make the state a cold mix that they used for adding shoulders to road. It works really well. But again, with the central mix plant, it has everything you need. It has the pug mill, it has the crushing and screening unit, and it's ready to go. Once we've produced the mix, we're going to load this into trucks and transport them to a laydown area. It handles now pretty much like hot mix, except it's just not hot, it's cold. We want to follow good paving practices. So prior to placing this mix, if it's on an existing asphalt pavement, it needs to be swept and tacked well prior to paving. We want to pave the recycle mix. One of the keys is when we need a heavy duty screed. This is a cold mix. It's quite viscous. It's hard to get it to go through the paver, so it takes a pretty high horsepower paver. We want to be sure that the screed is not heated. A lot of people think that heating that screed will aid in compaction, and the only thing it will do is cause the CCPR mix to stick to the screed, and it'll tear and drag and mess up the surface of your mix. So we want to be sure we do not heat that screed. Occasionally we bring these things out. We bring this cold central plant mix out in a belly dump truck. If we do that, we're going to dump it in a windrow, and we're going to pick it up with a windrow elevator and place it into the paver like you see down there at the bottom. But again, it's placed with typical with the screed just like you would a hot mix. The only difference is I do not want to heat that screed. Occasionally we'll see this in areas where they want to put down a very economical mix on a rural low volume road. And when you do this, it is possible. It can be done this way where they just do end dump and blade lay it. Seen it done on low volume roads and on places where they were making a pad for temporary parking and that kind of operations. The things you have to be aware of and be cognizant of with this process is you're going to be moving that material around with the blade, so you got to be careful to segregate it. And it's probably not going to go down as smooth as if it was placed with the screed. Compaction. Compaction is one of the keys to this, and the thing to remember is it's cold and it's going to go down at higher air voids than typical hot mix. So we don't compact this to a specified density based on maximum specific gravity like we do hot mix. We either use a rolling pattern and establish a target density, or occasionally people would compact it to a percentage of the mix design density. But we need to use heavy compaction equipment. So we recommend a pneumatic tired roller, at least 22 to 25 tons. And we want to see at least a 10-ton double drum vibratory steel roller. All your rollers are going to have working water spray systems to keep the mix from sticking to the tires. What we typically see with compaction is they'll hit it with 1 or 2 passes of the double drum vibratory roller, and then they'll roll it with the pneumatic tire roller until the pneumatic tire roller walks itself out. And then we'll hit it again with the steel wheel roller in the static mode to level it up and get those roller marks out of there. But again, compaction is critical. We want to pay attention to this and get the best compaction we can. Once it's done, we can open this up to traffic if necessary. So to protect it, if it's necessary, you might want to apply a fog seal to minimize raveling. We see this being required sometimes in an area that's shaded or with high moisture content or with a lot of type sharp curves that you might see in a mountainous area. So if we apply a fog seal, we want to put some blotter sand on there to avoid pickup of the fog seal, and then you can release this to traffic. If the mix is going to have to stay open for a while before you can cover it, we really don't recommend that, but that fog seal and blotter sand helps to seal the mix off and will help it shed water, So it's not a bad idea. Another thing we can do, we want this mix to cure out before we put the surface mix on top of it, and it does require a surface mix due to the high air voids. So we typically like to see 2 to 3 days worth of traffic on it before we cover it up, and we like to see that residual moisture content drop below about 2 to 3%. This is usually not a problem with cold central plant mixes, and it's not a problem with foam mixes, as the foam tends to cure fairly quickly. But occasionally we'll see instances where after 3 to 4 to 5 days you still haven't dropped below 3%. And what we generally recommend, if you haven't dropped below about 3% in about 10 days, if it hadn't rained in a couple of days, you need to go ahead and cover it up. With an emulsion, emulsions tend to go down, emulsion mixes tend to go down slightly over optimum. So what we call rerolling or supplemental compaction can be beneficial for an emulsified mix. We typically have done this right before we want to go ahead and place the overlay. So after 2 to 3 days of traffic, we're getting some information that you can re-roll it at the end of the day and usually pick up 2 to 3 pounds of extra density. But again, it's not usually required with foam asphalt. It doesn't usually work. Now, one of the things we want to watch out if we do this is we don't want to damage the mix. So it needs to be fairly warm. We generally recommend you want to do this when the air temperature is at least 85 degrees Fahrenheit or above. It may take a couple of passes before you start picking up density, so we want to put 3 or 4 passes on it as a trial to see whether this is going to work. And we want to discontinue this if we are seeing any roller checking or cracking or any type of distress. It may not work. And then lastly, we want to put on a final surface. Because of the higher voids, cold recycle surfaces need to be sealed to protect them from moisture. So we've seen all kinds of things put on these. We've put down slurry seals and microsurfacing for low volume roads and on shoulders and on parking lots. Chip seals are fairly popular. If you're in an area where there's used snow plows, you probably want to go with a double chip seal because you don't want to peel that chip seal off. The most common is we see an asphalt overlay. And then the thickness of that asphalt overlay is just determined from the structural design. As far as how well does this stuff perform? Again, Virginia's leading the nation in performance studies on cold central plant. They had the I-81 project and the I-65 project. And then they went down to NCAT and put down some test sections that mimic the I-81 project. Auburn also on the Lee Road 159, it was a pavement preservation study. They put down one section of cold central plant. Then they put down a section on US 280, which is just outside of Auburn, Opelika on a 4-lane road. And this last summer, Min Road built some test sections to mimic what they had done at NCAT. So we'll take a look at those real quick. So the VDOT test sections with CCPR at the NCAT test track, they had one section that had FDR. This was what was in the driving lane on I-81 at FDR, and then at 5 inches of CCPR and a 4-inch overlay. And then on the inside lane, they put 5 inches of CCPR over 4 inches of asphalt and 6 inches of asphalt. These were on the NCAT test track for 3 cycles. So they've been down about 8 years. They've had over 29 million easels on them, and they've had no distress. So with that much asphalt overlay on them, they have performed incredibly well. So one of the questions that came up was, well, that's for high traffic and a thick asphalt overlay on it. How would they work on a low volume road section? So they went to Lee Road 159, the pavement preservation study. And this is a dead-end road that goes into a rock quarry with an asphalt plant. So they know the number of trucks coming in and out, and they know the weight of the loaded trucks going out. So they have a pretty good idea of the easels or the traffic on the road. So it's a small 50-foot section, like all the test sections there, but they dug it out and they put in 5 inches of a CCPR mix, and then they put a 3/4 inch HMA thin lay over it. Was placed in 2012, so it's been down about 8 years, and they estimate it's had over 1.3 million easels on the outgoing or loaded side. And the performance has been really good. It has less than 4% low severity cracking in it, less than 3 millimeters of rutting. The IRI is a little high, but with a series of 50-foot test sections all down the road, the IRI is high. But the important thing is there's been no increase in the roughness or the IRI with time. So the section is performing really well with just a 3/4 inch thin lay on it for light traffic. So the next question that NCAT decided to do was, well, how thin can we go? So they went out to US 280, which is a 4-lane divided highway, just east of Auburn, Alabama there. It has about 16% trucks with over 18,080 AADT. And they put down some cold central plant sections and cold in place sections. These sections are long enough that they can get a recycling train in there. So they put a 1-inch thin lay over 4 inches of CCPR or CIR. Over 4 inches, there was 4 inches of old asphalt remaining there. Been down for about 5 years. It's got over 3 million easels on it. As far as cracking, there's been no cracking. It's in the good. The rutting, 2 of the sections have just dropped from good into just barely into the fair section. So they still said there's absolutely no concern about rutting. And the IRI on all of those sections have been good. And again, they put down emulsion sections and foam sections and are seeing really no difference in performance in them. And then finally, these are all warm sections. So up in Min Road, a little northeast of Minneapolis is the Min Road test section. And they went to a local county road. It was an existing road with 4 inches of asphalt, 6 inches of granular base, and a clay subgrade. There's a series of 550-foot test sections they put down there. There's 2 CCPR sections that are 3 inches deep with a 1-inch HMA thin lay with 1 inch of asphalt left on there. They did foamed and emulsified asphalt. They put 1% cement in the foam section. They're performing well. They haven't been down very long, but the estimated 20-year ESOLs on this will be 1.25 million ESOLs. So this will be interesting to see how these things perform in a very cold climate. So in summary, kind of an overall background of CCPR, but really CCPR can be used anywhere where one would place an asphalt base mix. CCPR is an economical alternative to new construction. It is very sustainable. We're going to use the material you've already bought and paid for. So we're going to reuse existing materials. We don't have to go quarry out new materials, and we're going to place it without heat. So it's a very green process. And finally, CCPR has a history of good performance. So with that, I'm going to wrap this up. Thank you for your attention.